So now that you've seen kind of a high-level view of this program, let's start talking about how we're going to apply completable futures here. So the place in which completable futures are applied is a hook method called processStream, and this is where the whole control flow lurks. The first thing we're going to do is we're going to get a list of URLs from somewhere, and the somewhere could be from the command line, from some user dialog box. You could download it across the network. You'd read it from a file, wherever it comes from. We don't really care. We just have a list of URLs that are input by the user somehow. What we do then is we have this sequential stream that does all the asynchronous. It triggers all the asynchronous processing. First thing we do is we convert the URLs list into a stream. So now we have a stream of URLs. And at this point, things get quite different from the parallel streams version. Parallel streams version only looks superficially like what we're about to talk about. What we're going to do here is we're going to asynchronously check to see whether we've already downloaded these images. If we've already downloaded them and processed them and stuck them into a cache, we're going to ignore them, because why re-download them again? They're already there. They've already been processed. So that's where things start. We're going to asynchronously do this. And what this map call does, and it may take a while to get your head around why it does it this way, but it's really cool. It converts a stream of URLs into a stream of completable futures to optional URLs. And you'll see why we convert them to optional URLs in a second. The reason we convert them to optional URLs is because if they've already been downloaded, we don't want to download them. So in that case, we're going to make the URL optional be empty. So those things will be ignored. What we then do is we take that stream of completable futures to optional URLs, and then we map it again, except this time we map it to another behavior called download image async. And what download image async does is it will take the completable future that it's been passed, and when that future is triggered, in other words, once we've figured out whether something is cached or not, we will then end up with an optional URL. And if that optional URL is empty, we're just going to ignore it. If the optional URL is not empty, then we're going to go ahead and download the URL that's part of the optional URL state. So this is going to basically convert these futures that have completed, when they complete, to image futures that are in the process of downloading asynchronously. So now we end up with a stream of completable futures to optional images, because download image async is going to convert the URL to an image, but it's going to be optional image, because if it was an optional URL and it was empty, we're going to keep this thing empty. So anything that's empty will just be ignored on the way down through the chain. So then what we're going to do is we're going to take this stream of completable futures to optional images, and we're going to call the flat map intermediate operation, and that will convert the image futures that are non-empty when they complete. In other words, once they've finished downloading, they'll be converted into filtered image futures. And what that means is that these filtered image futures are completable futures that are in the process of being transformed by image processing transforms and then stored. And all that stuff will take place asynchronously. This is the most complicated behavior in the whole stream path, really. What we then end up with is a stream of completable futures to images that are in the process of being transformed and stored. And then we're going to go ahead and collect everything, and we'll talk about what collect does in a second. And collect, as you might expect, is going to take that stream of completable futures to optional images, and it will return a single completable future, which will trigger only when all the other asynchronous processing is finished. And there will be a lot of asynchronous processing, because we're downloading the images, we're checking the caching asynchronously, we're downloading the images asynchronously, we're transforming and storing asynchronously. And if you have a lot of images, there's going to be lots of asynchronous stuff queued up in the worker thread decks in the fork join pool. And we're going to end up with one and only one completable future to this whole kit and caboodle. And when that future completes, in other words, after everything else is completed, then we're going to go ahead and apply this action. And what this action is going to do is it's going to go ahead and log the number of images that we've successfully downloaded and transformed and stored. So it's just going to log that information. And we'll talk more about this here in a minute. And then finally, the very last thing we stick in this whole long stream pipeline is a call to the join method, which, as always, waits for all the other processing to finish asynchronously. So this join call will block until all the images have been downloaded, processed, and stored. And this is the one and only call in the entire implementation of this particular variant of the asynchronous completable future example that blocks. Nothing else blocks. Everything else is done asynchronously. OK, so that was just an overview of kind of the flow, showing kind of the tree, the forest level view of how the flow occurs. Now we're going to dive down next into the tree level view of each of the individual steps and behaviors.